In this chapter, we're going to review some topics in algebra that will help prepare us for the calculus course that's coming up. In this lesson, we'll be looking at concepts in coordinate geometry. And we'll begin by briefly discussing the idea of slope.
All right, so we're going to take a look at some ideas in coordinate geometry, some stuff that's significant to where we're going to be going in this course. And we'll start off with this question right here. It says, find the slope of the line that passes through the point P, negative 3, 3, and Q, negative 2, negative 6. In other words, we're just finding the slope of the line segment joining those 2 points there. Okay, well, what you've got to remember is what slope is. Okay, slope, okay, is, whoops, I don't know why I'm starting with that. Slope is going to be the ratio of rise over run. Now, I'm going to throw some other notation here. I could jump right to the equation here, but I want to talk about it like this, which means it's going to be delta y over delta x, change in y over the change in x. And we know, okay, at least at this point you should be familiar with it, that it's going to be that second y coordinate minus the first one divided by the second x coordinate minus the first one, okay, comparing the 2 points. This is an incredibly important concept for this course, this idea of slope. You'll see why in a little bit here. But this is a fundamental idea, rise over run. And so now with the 2 points that I've got up here, if I say that this is my second point, then I would do negative 6, and I would subtract 3, divided by negative 2, subtract negative 3. Okay? And then this, well, negative 6 minus 3 is going to be negative 9. Negative 2 minus negative 3 is the same as negative 2 plus 3. It's going to be 1. So my answer here, my slope, would be negative 9. That's what we're looking for. So this is the ratio, okay, of rise to run.
Now we'll review the distance formula.
All right, in this question here, we're being asked to show algebraically, okay, that the triangle with the following vertices, here we go, A is 0, 2, B is negative 3, negative 1, C is negative 4, 3. We're going to show that this is isosceles. Okay, well, now I got to know what isosceles means. Okay, and isn't that the case with most things mathematics? You just got to know what the definition is before you can move ahead here. So isosceles means that that 2 sides there are the same length. Okay, so I got to figure out the lengths of these sides here, and I'm going to do that using the distance formula. And so if that's not familiar to you, and that might not be, the distance formula is basically an adaptation of the Pythagorean theorem. So it's going to be the change in the x coordinates squared plus the change in the y coordinates squared, square rooted there. Okay? And so if you just have a good look at that, basically this is the length of the hypotenuse is the bottom or the base squared plus the height squared, and away you go. So now what we're going to do is we're just going to take pairs of points here. Now bear in mind how this would work here. If I'm going to figure out the distance from A to B, that's going to be point C. Okay, that's going to be the length, okay, the length of line segment C or in that triangle. Okay, so that is going to be, and I'll do it like this. If I compare A and B, so x2, so negative 3 minus 0 squared plus negative 1 minus 2 squared. Well, this is going to be the square root of, okay, well, negative 3 minus 0 is going to be negative 3 squared is 9. Negative 1 minus 2 is negative 3 squared is 9. So 9 plus 9, this is going to be 18, okay, which I can simplify down to 3 multiplied by the square root of 2. Now, I didn't really need to do that, and you'll see why in a second here. This is really as far as I needed to go. Let's try another one here. Let's say that we're going to figure out the length of, I don't know, let's say side AC. Now, AC, if I was to connect those two vertices here, that would be the length of side B. Okay? Little b. So that'll be the square root of, now let's take it like this, negative 4 minus 0 squared plus 3 minus 2 squared. All right? So x minus x squared plus y minus y squared. Let's see what we get. That is the square root of, well, negative 4 minus 0 is going to be negative 4 squared is 16. 3 minus 1 is, sorry, wow. I was anticipating the answer there. 3 minus 2 is 1, squared is 1, so put those together and we get the square root of 17. Now, that's a prime number. I really can't simplify that beyond the square root of 17, but I know that those two are not the same. Okay? All right, so now I've got to find the length of a line segment A, little a here, and that's going to be the distance between B and C. So the distance along little a will be the square root of, okay, well here, let's make this our second point here. So negative 4 minus negative 3, whoops, minus negative 3, I should say there, squared, and we will add to that, what do we got here? 3 minus negative 1 squared. 3 minus negative 1 squared. All right, well, negative 4 minus negative 3, that's going to be negative 4 plus 3 is negative 1 squared is 1. 3 minus negative 1 is going to be 3 plus 1, so 4 squared, so it's going to be 1 plus 4 squared is 16, this is root 17. So, oops, sorry, so there you go. So now you can see that since the distance, the length of A is equal to the length of B, therefore this is isosceles. That's the conclusion we can make. There we go.
The next question focuses our attention on the slope-intercept form of the equation of a line.
All right, so for this next little set of questions here, we're going to find the slope and the y-intercept of the following. Okay? So slope and the y-intercept here. So let's start off with something that looks like this. X plus 3y is equal to 0. Okay, well, I mean, I can see it's a linear function. I've got x and y there. They're both to the power of 1. They're both linear. I'm going to solve for y. So 3y is going to equal negative x. And then I'll divide by that 3. So negative x over 3. I can make that x look a little bit better. Sorry about that. Negative x over 3 plus 0, blah, blah, blah. There it is. There, we're done there. Now, this equation is now in what we would call slope y-intercept form, slope-intercept form. Okay? The coefficient of x is going to be the slope, so therefore our slope is going to be negative 1/3. Now our y-intercept would be the number that we're adding out back here, or if you want to think of it this way, let x go to 0. But if x goes to 0, then y equals 0, so our y-intercept here is simply going to be 0. There you go. Let's take a look at another one here. What if the function was 3x minus 4y equals 12? That's a little bit more complicated, but really not that much. First we're going to bring that 3x term over. We're going to try to isolate the y to once again put it into slope-intercept form. So I'll subtract that 3x from both sides. Now I'll divide by the negative 4, so y will equal 3/4 x minus 3. Now, taking a look at that, I know that my slope is the coefficient of that independent variable there, so it's going to be 3/4, and our y-intercept is negative 3. Again, if I make x equal to 0, you're left with negative 3. Good. So it should be easy enough to do once you isolate the y. Now, take a look at, it's got to focus here. There we go. Take a look at this one. What if the line is y equals 7? Okay, well notice that the y is already isolated. Okay, that means this is naturally in slope-intercept form. But the slope is always the coefficient of the independent variable. But you're not seeing the independent variable here. Well, the only reason you're not seeing it is because its coefficient is 0. So that means the slope of this particular line segment is 0. The 7 is taking the place of the y-intercept. Okay, slope is 0, y-intercept is 7. Now, what that means is this is a horizontal line. Okay? Slope being 0, we're talking about a horizontal line. Now, compare that to this last one here. If I tell you that the equation is x equals 3, now notice in this particular case here, I can't solve for y. I cannot write this expression explicitly in terms of x, as a function of x to get y there. It just doesn't work like that. And the reason why this is such an oddball one here is because this is not a function. Okay? It's not a function. Well, now think about this. It's still linear. Okay, it's totally linear because the exponent on here is 1. So what's the only kind of line that isn't a function? The answer is this is a vertical line. That's why, that's why it's not a function. So now the slope becomes a little bit more obvious here. If it's a vertical line that we're dealing with, then the slope is undefined. And in this case right here, when I tell you that the x is equal to 3, what I'm doing here is I'm establishing a characteristic of this line that differentiates it from everything else here. When I say x is equal to 3, I mean every x-coordinate of every point on this graph is 3. Well, when I ask you for a y-intercept, the implication there is that the x-coordinate is 0. But that doesn't happen. If all of the x-coordinates here are 3, then there is no y-intercept. There's no point that could possibly satisfy what's required to get a y-intercept in this particular scenario. And that actually makes perfect sense because this is, if you want to look at it like this, this is going to be a vertical line over here where x is equal to 3. It will run parallel to the y-axis. Not the way I've drawn it there. That looks a little like it's off there, but you get the idea.
In this final question, we will practice finding the equation of a line given different bits of information.
All right, now for this question here, we're being asked to find the equations of the lines that satisfy the following conditions. Okay, so we're just going to grab a bunch of these here. So let's say we are looking for the line that travels through the point 1, 7 with a slope of 2/3. Okay, now there are multiple different versions of the equations of a line. I would really recommend that for the most part you stick with the point slope form of the equation of the line. So the one that I'm going to typically work with is the one that looks like this. Y minus y1 is equal to the slope times x minus x1. This is going to be my go-to, okay, because it's very quick and easy to use. And so the way this one works here, the slope of 2/3, that's m, and then I just have to identify a single point and plug that in for x1, y1 here. So in this particular case, what I would get immediately is the line y minus 7 is equal to 2/3 x minus 1. Done. And I can move on to the next question. And in fact, that's what I'm going to do here, because I want you to get comfortable with this. I know that in a lot of cases we go back to the slope-intercept form. The purpose of that is really just to make people do a little bit more algebra. Okay? And there's nothing wrong with that at all. It's good to practice that. But this is what we need. So how about we're going to come up with the equation of a line that satisfies the condition that's got to go through the points 2, 1 and 1, 6. Now, I just said that I like using the point slope form. Well, I've got two different points that I can use here. But what I don't have is the slope. So I got to spend a few minutes here, or a few minutes, this shouldn't take me a few minutes, but it should take a few seconds here to figure out what the slope is. And that will be y2 minus y1 over x2 minus x1. All right, well 6 minus 1 is going to be 5. 1 minus 2 is negative 1. 5 over negative 1 is going to be negative 5. And so there's my slope. And so now, using the point slope form, and I can use either one of those points, so I could write either y minus 1 is equal to negative 5 x minus 2, or if I wanted, y minus 6 is equal to negative 5 x minus 1. Yeah, both of those are great. Doesn't matter which one you want to use here. Okay, what if I give you this information? What if I tell you that it's got an x-intercept of 1 and the y-intercept here is negative 3. Now, what I want you to recognize from this one here is that this is really a very similar question to what we just did. Because if I give you the x-intercept, what I'm telling you here, what I'm trying to say without directly saying it, is that the y-coordinate is 0. Just like over here, if I give you the y-intercept, what I'm trying to tell you is that the x-coordinate here is 0. Okay, so I'm really giving you 2 points. Now that doesn't alter the fact that I still need to figure out the slope. In order to come up with the equation of the line, I need that slope here. So let's say y2 minus y1, so negative 3 minus 0, divided by 0 minus 1. And so that's going to be negative 3 divided by negative 1, so that'll be positive 3 here. Now, I would normally jump on using the point slope formula. But you got to understand my motivation here and why I'm not going to use that in this case. It's because I'm so ridiculously lazy. Okay? I normally use the point slope form because I don't have to do anything once I've got the point and the slope here. Now, in this particular case though, I've got the slope, and one of the points that I have is actually the y-intercept. So it makes more sense for me to use the slope-intercept form because I have those pieces readily available. And that really does, I mean, when you compare how they look, this is a simpler looking expression than what you get up here. So when I can, when it's very simple to use the slope-intercept form, I will. Okay. Let's try another one here. Let's say, what do we got here, D. Let's say the point through the point 4, 5, and let's say parallel to the x-axis. It's probably off the screen. Yeah, there it is. Parallel to the x-axis. Okay, well, it's this last little bit here that is significant to me. Parallel to the x-axis. Now, the x-axis runs this way, so parallel to the x-axis is going to be a horizontal line. Okay, I already know that in a horizontal line, the slope will be 0. So this is going to be 0x, okay? And actually, sorry, I might do it like this. Just to show you where this is going here, I might do it like this. I've got a point, and I already know that the slope is going to be 0. So this is going to be y minus 5 is equal to 0 times x minus 4. There we go. I used my point slope form. However, I hope you see this. What's 0 multiplied by x minus 4? 0. And so this really becomes y minus 5 is equal to 0. Or if you will, y is equal to 5. That's sufficient to write that relation. Okay. Let's do a little similar to that. Just make sure I'm on the right. Whoops, E. Let's try through. What do we got here? 1, negative 6, and let's say parallel to 2x. Oh, sorry, not 2x. I'm looking at my example here. 2x plus 2y equals 6. Okay, so again, I lean towards point slope form. I've got a point, which is great. I sort of have a slope, but it's kind of hidden inside here. So what I got to do here is I got to grab it out of here. So to do that, I'm going to isolate the y. So negative 1/2 x plus 3. All I needed from this expression was the slope, because the question said it was supposed to be parallel to this line. The slope here is negative 1/2, so the slope of the line that I'm trying to build is going to be negative 1/2. Okay? Now, I know that my line is going to go through this point right here, so my equation would therefore be y plus 6, okay, minus negative 6 is equal to negative 1/2 x minus 1. Okay, there you go. So I grabbed the slope from this line because it was supposed to be parallel to it, going through that point right there. Next, let's say through negative 1, negative 2, but this time let's say it's perpendicular to, what do we got here? 2x plus 5y plus 8 equal to 0. All right, so going through this point right here, but perpendicular to this one. Now, and you should have anticipated this one. It makes sense that I would ask a couple questions where the lines are parallel, and then all of a sudden something where they're perpendicular here. Again, the issue is about the slope. So the first thing I'm going to do is try to isolate the y here. Whoops, no, not 5. I'm going to isolate the y. So y will equal negative 2/5 x minus 8/5. Slope y-intercept. So my slope here is negative 2/5. And that means that therefore the slope that I need has got to be perpendicular to that. So change the signs, reciprocate it. The slope that I'm interested in is this 5/2. And so now y minus negative 2 will equal 5/2 x minus negative 1. Okay, there we go, again in point slope form. And now finally, how about through, say through the point 6,3, and again, let's say perpendicular to the x-axis. Perpendicular to the x-axis. Now, perpendicular to the x-axis, think about that. The x-axis goes this way, so perpendicular to it's going to be this way. So we're talking about a vertical line here. Which means, everybody, this is not a function. So I can't, okay, whoops, yeah, my handwriting is terrible. I can't just expect this thing to fall into the category of y equals something. It doesn't work like that. But with a vertical line, and remember we discussed this a little bit earlier here, all of the points on a vertical line are going to share the exact same thing, and what they're going to share is the same x-coordinate. So if I have one point on that line, then I know something about every point on this line. And in this particular case here, I know x is going to equal 6. Okay, so now you can either write the equation of the line like that, or if you want, you can write it as x minus 6 equals 0. In either case here, that's going to be what we're going to use for the equation of this particular line. Okay, I hope that helps.